Okay, today we are going to study about deflection of truss joints. इसका मतलब when we have a truss, let's consider or draw a truss like this. So this is a truss which is statically determinate. We will study about indeterminate truss also. Let's consider the support reactions are like this, and the loading system is like W1 and W2 and W3 are applied in these points. Okay, so if we consider this is member 1, there can be the member force be P1, this can be P2, this can be P3, this can be P4. Similarly, we can number all the members. Okay, now if we are asked to find out the deflection of any joint, it can be this joint or any joint, so we have to apply Castigliano-Fast theorem to solve this kind of problem. Let's consider we are asked to find out deflection of this point, so I am naming this as point C. So due to the loading condition, यहाँ पे जो deflection होगा, let's consider that is YC. Okay, we need to find out this deflection. Okay, so now due to this loading condition, if we are going to apply first theorem of Castigliano, let's find out the total strain energy stored by the structure. Okay, so this can be, let's consider WE, the work done. The strain energy must be equals to work done, so this will be equals to strain energy again. Okay, so this work done can be found out by the formula using P1 square L1 divided by 2A1 E1, summation of all the members. We have already studied about this while studying about strain energy. Okay, so now in this equation, what are L1 and L2, L3? L1, L2, L3 are lengths of each member. Okay, what are A1, A2 and A3? These are cross-sectional areas. Okay, what are E? Modulus of elasticity can be different, so generalized E can be written as Young's modulus. Okay, now this is the total work done or energy stored in the truss. Now to find out the deflection, the way we studied about analysis of redundant truss, here also we need to apply a unit load at a point where deflection is desired by removing all the loading conditions. So if I draw the truss again and remove all the loading condition, so I can draw like this. So this is the truss. Okay, and there will be obviously support reactions. Okay, now there is no external loading because we are going to remove all the loading conditions, and we are going to apply a unit load where the deflection is to be desired. This is point C. Let's consider a unit load 1 is applied at point C. Okay, now due to this application of point load, the member forces can be K1, K2, K3, K4. Similarly, for all the members we can numbering. Okay, now due to application of this unit force at point C, we need to find out the work done. Let's consider due to application of this point load, यहाँ पे जो deflection होगा, that deflection is del YC. Okay, now work done, the work done due to this application of unit force is given by, क्या होगा, half into the applied load is 1 into del YC. Okay, now this is the work done due to this application of unit force. Okay, what can be the strain energy stored? Strain energy stored, this can be written as by applying द फॉर्मूला ऑफ फर्स्ट थ्योरम ऑफ कास्टिग्लियानो क्या होगा, k1 स्क्वायर L1 डिवाइडेड बाई 2a1 e1 summation of all the members. Okay, now this must, as work done and strain energy are same, we can write this as half del yc is equals to summation of k1 square L1 by 2a1 e1. Okay. Okay, now let's consider, already the unit force is applied, along with this the external loading system is also applied. Okay, so I'll draw another figure here, okay, so that there will be no confusion. So already the reactions are there and a unit force is applied. Along with this unit force, we are going to apply the external loading system. Okay, W1, either W2 and W3. Okay, so now for this system, what will be the work done, total work done? So we can write this total work done कितना होगा, this will be equals to this WE plus WE due to the external loading condition. Now due to this unit force कितना work done हुआ था, half into 1 into del yc. Okay, now as unit force is already applied and we are going to apply another external loading system, so the virtual work done will also be added to this. How much work done? The applied force at this point is 1 into deflection due to the external loading system कितना, yc. So now this is the total work done. Okay, now here as both the loading condition are there, what will be the member forces? P1 plus K1, P2 plus K2, P3 plus K3. Similarly for all the members it will be found out accordingly, P4 plus K4. Okay, so total strain energy stored कितना हो जाएगा अभी, total strain energy energy stored. What will be the total energy stored? If we apply the formula of summation of loading square, तो क्या होगा, P1 plus K1 square for this member into L1 divided by 2A1 E1 or E. Okay, now this is the for both the loading condition, summation for all the members. Okay, so total work done and total strain energy stored, they must be equal. So we can write this as WE plus half into 1 into del yc plus 1 into yc must be equals to summation of P1 plus K1 whole square into L1 divided by 2A1E. Okay, now let's simplify this A plus B whole square. So I will write this as क्या होगा, WE plus half into 1 into del yc plus 1 into yc is equals to summation of P1 square plus K1 square plus 2 P1 K1, this is the A plus B whole square, into L1 divided by 2A1E. Okay, if you simplify this again, we can write this as WE plus half into 1 into del yc plus 1 into yc is equals to summation of, can I write this as P1 square into L1 divided by 2A1E plus summation of K1 square into L1 divided by 2A1E plus 2P1 K1 L1 divided by A1E to summation. Okay, so now do the simplifications. WE, so we already know WE, how much WE is P1 square L1 square by 2 1A. So this term and this term are same, so they both will be cancelled out. Okay, we already know half into del into 1 into del yc is this term, so this term and this term will cancel out each other. So from this we get yc value kitna, so yc will be equals to summation of p1 k1 l1 divided by a1 e. Okay, so if we know the p1 due to external loading system, k1 load member force due to the unit force, then finding out deflection at any joint of a truss is very easy. So we are going to apply this formula to a problem and solve this problem.